Good afternoon, members of the executive team. My name is Enrique Rascon. Thank you for joining me today's network status briefing. Today's goal is to give you a clear, high-level overview of the current state of the Canyon Woodcraft network. Here we have our agenda. For our agenda, I will be discussing network design overview, corporate network technologies, branch office configurations, network security measures, access and management tools, implementation, and final closing statements, followed by answering any additional questions you all might have. Here we have our network design overview. As you can see, the Phoenix corporate office serves as a main hub. Branch offices include Austin, Denver, and Flagstaff. Flagstaff is viewed here, all interconnected via OSPF for dynamic routing, which I will get into later down on the slides. Ether channel used for link aggregation and so on. So let's start off at the heart of our operation, the corporate office. To prevent network outages and reduce downtime, we've implemented spanning tree protocol, or STP. Simply put, STP prevents accidental looping in our wire networks, which, if left unchecked, can cause major disruptions. It's like setting up the traffic lights at busy intersections and keeping data flowing smoothly. Alongside that, we're using Ether channel, which lets us bundle several physical links into one logical connection. This boasts our bandwidth and adds redundancy. Think of it like using multiple lanes in a highway. Even if one lane closes, the traffic keeps moving. Next slide. OSPF between branches. Between Phoenix, Austin, Denver, we use OSPF. Or open shortest path first. This is a dynamic routing protocol, and it continuously learns and adapts best paths for data to travel between these locations. If a link fails, for example, between Phoenix and Austin, OSPF immediately reroutes traffic through the next best available path. This ensures that our remote branches stay connected without interruption. It's a cornerstone of our reliability. Next, we securing the networks via ACLs, port security, DHCP snooping. Security is a top concern, and we have deployed multiple layers to keep our network safe. ACLs, or access control lists, act like gatekeepers at a data level. They determine which devices or user are allowed to access certain parts of the network. This limits exposure and keeps unauthorized traffic out. Port security locks down individual switch ports, allowing only approved devices to connect. This is especially useful in physical locations like conference rooms or public desks. And finally, DHCP snooping protects against rogue DHCP servers. These rogue servers can cause chaos by assigning incorrect IP addresses. DHCP snooping ensures only trusted servers assign those addresses. Combining all these tools help us enforce a zero trust security model. Next, net configuration or network address translation. NAT hides our internal IP addresses when communicating externally. Think of it like a reception who fields all incoming and outgoing calls without revealing the internal extension. It enhances security and converts IP addresses. Now we get into DHCP servers. Each of our key branches, Austin, Denver, and Flagstaff, runs local DHCP services on their routers. This means devices in those locations can connect and receive their network settings automatically. It simplifies setup and reduces manual configuration, especially important during moves or hardware upgrades. Managing network devices via Telnet, SSH, SNMP. Telnet is outdated and insecure. We avoid it unless absolutely necessary in controlled lab. SSH is our go-to tool. It encrypts traffic and ensures safe remote access. SNMP, or Simple Network Management Protocol, is a key for monitoring. It allows us to track device performances and automate alerts. However, if misconfigured, it can become a security risk, which is why we've hardened SNMP settings across all devices. In summary, we prioritize secure management protocols and continuously audit access points. We arrive at our overview. So let me bring this full circle. Every component I've discussed today, from STP and OSPF to DHCP and SSH, was chosen and implemented based on Canyon Woodcraft's operational needs. For example, when we optimize routing between branches, the result is reduced latency for all shared services. Our ACL and GCP snooping deployments have already blocked unauthorized attempts on guest networks, and our use of Ether channel has double backbone capacity without additional hardware, reducing costs. Finally, we come to our conclusion. To wrap things up, we've built a resilient, scalable, and secure network that not only supports daily operation, but is also ready for growth. Future phases will focus on increased automation and stronger network analytics to keep us one step ahead of those who seek to do harm on us. I want to thank you all for your attention. I will take any questions now or any feedback. Thank you for having me.